Hi guys, so in this video we're going to be talking about Le Chatelier's principle and equilibrium because this comes up a lot with multiple choice questions and even FRQs. So Le Chatelier's principle is defined as if a stress is applied to a system at equilibrium, the position of the equilibrium will shift in the direction which reduces the stress. So one way for this to happen is removing a reactant or a product. So essentially the equation will shift to compensate for the loss or the gain of a reactant or product. And it will try to get to the original state of equilibrium, where the concentrations are constant. So another way to do this is increasing pressure or decreasing pressure causes the equilibrium to shift to the side containing the fewest number of moles of gas. And like I said before, the opposite's also true, where decreasing the pressure causes the equilibrium to shift to the side containing the greatest number of moles of gas in order to make more pressure. So smaller volume means less disorder, which is what we want. So adding a catalyst is a little bit different. Adding a catalyst to a reaction causes no shift and has no effect on K. It'll just make equilibrium become faster. It'll come to equilibrium faster, which has to do with rate and kinetics. So changing temperature is the only way to change the coefficient of equilibrium. So that's just one really important factor to know. And we're going to talk about some examples right now. So this has to do with temperature increasing and decreasing. So essentially, if a reaction is endothermic, meaning it has a positive delta H value, the heat is in the reactants. So if temperature is increased in this case, it's going to be adding temperature to this, which basically, if you think of delta H as a reactant, it'll have more reactants. So then it'll have to shift to get rid of some of the heat and shift to the products. So for exothermic reactions, if you have a negative delta H, it's on the products. So let's say we're also increasing the temperature. You're increasing the products, so then it has to shift to the reactants. So for this question, when it asks when the addition of carbon monoxide happens, it's adding the gas in the product side. So that means it's going to shift left to the reactants because there's more of the product, so it has to compensate for that. Okay, so for B, the addition or removal of carbon or AS406. So that means it's asking about the reactants. But don't be too quick to judge that it would shift the other way because these are both solids. So in this case, the equilibrium position will not change if you add or subtract the amount you have of this because they're both solids and they are not in the equilibrium constant. So that's no shift. And the removal of AS4 would cause it to shift right because you're removing some of this and you need more of the partial pressure of AS4 like you have at equilibrium. So this has to do with gases and the moles of gases on each side. So predict the shift in equilibrium position that will occur for each of the following processes when volume is reduced. So we know from the past that when volume is reduced, pressure is increased because there are more collisions with the side of the container. So the preparation of liquid phosphorus trichloride in the reaction P4 solid plus 6Cl2 gas yields 4 PCl3 liquid. So when volume is reduced, pressure is increased. So pressure is increased, so it's going to have to go to the side with less moles of gas, which is clearly the right side because there are no moles of gas. On this side there are 6, so it's going to shift right. For B, the preparation of gaseous phosphorus pentachloride according to the equation. So in this case, if pressure is increased, it's going to also go to the side with less moles of gas, which is the right side because there's 1 mole of gas here as opposed to the 2 moles of gas here that are combined from the reactants. So lastly, for each of the following reactions, predict how the value of K changes as the temperature is increased. So since this equation is endothermic, that means you can imagine the 181 kilojoules on the reactant side. So when temperature is increased, there are going to be more reactants, which is going to make it shift right. And when the reaction shifts right and there's more products, that means K is increased because more products means it's increasing. More reactants means it's decreasing. So delta H in B is negative, so we're going to have to add that we're going to pretend that we're adding that to the product side. So when you're adding temperature to the product side, which is going to increase the total products, you're going to have to shift left, which is going to decrease the value of k. I hope this helped Le Chatelier's principle. Thank you.